Hey, I'm Effie, and today I want to talk about images and images on Android and how you get started with adding images to apps and what is a good image experience. So first I just want to cover the basic of what is an image and what is a bitmap. So a bitmap is basically a basic structure that contains image data. And bitmaps are defined as sort of this like regular rectangle mesh of cells called pixels. Each pixel contains a color value, and they're characterized by only two parameters: the number of pixels and the information content per pixel. So each pixel in a bitmap contains certain information, usually interpreted as color information. And that information content is always the same for all the pixels in a certain bitmap. And by color information, I mean RGB, RGBA, maybe grayscale if you're really going really basic. So usually bitmaps in the operating system are represented as just an array of bytes. And the bitmap also has information stored usually as the file properties, such as the height and the width of the image, and how many bits per pixel describe that pixel. And the number of bits devoted to an individual pixel then determines the number of colors that can be assigned to that pixel. So for example, if we're talking about 8 bits per color info, it means that those are a lot of the images we'll see on Android, which are either RGB or RGBA, which means that every byte will contain red, then another byte will contain blue, then another byte will contain green. And again, if it's the 32 bits, then we're talking about the same thing plus the alpha channel. That means that if we want to go over this array, we'll just go by chunks of 3 or by chunks of 4 and read these 4 bytes. There'll be one pixel, one color. The next 4 bytes will be the next color, the next pixel. And there are ways to sort of make this a little more economical, because this takes a lot of space, and this is a really, it means that this is a really huge array. And index color is a way to do that. Just if you go back to your childhood where you had this like index where you'd be like, color all these, you had this like picture that you would be like, okay, all the spaces that are marked with 2, color them with green, and you would take your green pencil and color them. Color index is exactly that. There is a small palette on the side. The palette says, everywhere there's 2, put this color, draw this color, and then you can store, instead of 4 bytes per pixel, you can store only 1. And then go back to the index every time and read what does that color really is, and draw that color. When we're talking about image formats, there are 2 broad categories to talk about image formats. The first one we talked about already is a bitmap. The bitmaps are, again, really big, and usually they're not super economical. It takes a lot of space to store really big bitmaps. So a lot of times we would try to compress them and make the image size smaller. And there are 2 categories of compression. One of them is lossless, so it means the information is retained perfectly. And the other one is lossy, which means that we lost some information, but often that information or that loss will not be distinguishable to the human eye. And among the formats that we'll see very often, especially on Android, that are supported on Android, are GIFs. And these are paletted images, and they store at most 8 bits per pixel, so they are limited to 256 colors. one color in a GIF can be designated as transparent. So the image will have the background color of any background that displays it. And a sequence of GIFs images can be stored in a single file to form an animated GIFs. And GIFs are compressed, but no information is lost. So a decompressed image is exactly the same as the original. The next format is PNG. Again, it's a shorter instruction list. The PNG format is sort of an advance over GIF. It has many of the same advantages. You can have a transparent background, but it is a little more rich in color. You can display full color information. And again, PNG files are compressed with no loss of information. And the last format that is really common is JPEG. For JPEG, what happens is that for our image, mathematical formulas are created to calculate sort of a graph that approximates the original image. And some information is lost in this compression process, but often the loss is imperceptible to the human eye, especially if you choose like a higher compression. And JPEG images store 24 bits per pixel, so they are capable of displaying all the colors. And the last thing to know is that JPEG compression usually doesn't work too well for drawing blocks of solid colors and sharp boundaries, because it creates a graph out of your image. So it really is good for like nature scenes and curves, but not really for sharp endings. The next basic concept that I want to talk about is resolution. And resolution is the size of the screen or the size of an image. How many pixels is the screen composed of, and how many pixels is the image composed of? Which sounds super simple, but pixels do not actually have a numerical real-life value. Pixels are sort of like an imaginary concept. So there's another term to describe that, which is called density. And density is how many pixels fit in a certain space. How dense is your screen? So usually what we'll see in many cases is that bigger, further away screens are often less dense. Our TV is way less dense than our phone. That's because that's how usually the human eye works, where we can notice a lot more things up close than we can up far. And density is again used to describe how many pixels per inch, how many pixels did we sort of mash together in an inch. So that means that, for example, if we take a 48 on a 48 image for this is our baseline, this is like our 1x pixels, then if we wanted to make that image look similar and not blurry on a higher density screen, it means that if we take it and want to display it on a 1.5x, what we would see is that these pixels, they are bigger, and then we would see the images being blurry. So if we wanted to display the same image on a more dense screen, we would need to increase the number of pixels, in this case to 72 by 72. Another format of images that we'll see a lot on Android is vector images. So, like I said, bitmaps images are stored as a series of pixels. Each pixel is actually a very small square that is assigned a color, and when arranged in a pattern, when arranged in rows, they form the image. So when you zoom in on a bitmap image, you can see the individual pixels, because you will just see that each pixel becomes bigger. Unlike bitmaps, vector images are not based on pixel patterns, but instead they use mathematical formulas to draw lines and curves that can be combined to create an image from geometric objects, such as circles and polygons. Vector images are manipulated by manipulating the lines and curves that make the image. So when a vector image is scaled up, the image is redrawn using the same mathematical formulas. So the resulting images is just as smooth as the original. And mostly you will see this format supported by everywhere in the world, which is the SVG XML format to display vector images. And Android has its own vector images XML format. So Android also supports vector images. Vector images are really good to display sort of basic things like things that are one color, things that aren't like too complicated to write mathematical formulas for. There is an easy way to convert between the SVG format to the Android vector images format, which is, I think it's new on Android Studio 3.1, but it just means that you can import a vector asset, give it an SVG file, and it will format it and convert it into the Android vector image format. Now, a few things to know is that, again, these are XMLs. I'm going to flip back a little bit. So if something doesn't look right and you're really dedicated, you can go in here and change up the formulas or change up. Sometimes you might find yourself playing with the ratio, for example, the width and the height. And another thing to notice is that sometimes Android Studio will display an error here, which means that it could not convert all the XML tags, some properties it doesn't know about or cannot convert successfully, but it doesn't mean the image will not be converted successfully, it just will ignore these particular tags and attributes that it doesn't know. I wanted to cover the basics of drawing in Android and the basic classes that are used to draw images on Android. The very basic class is the canvas. And the canvas is a class that holds the draw calls directly to the operating system, the GPU. And to draw something, in Android, you need 4 basic components. You need a bitmap to hold the pixels, and the canvas in this case is holding that bitmap. So the canvas will draw anything that's drawn to it into that bitmap. It needs a canvas to hold the draw calls and writing into the bitmap. It needs a drawing primitive, like it needs to know what to draw, like a rectangle or a text or a bitmap. And it needs to have a paint to describe what colors or what styles we need for these drawings. And the canvas, other than the bitmap, that is the actual pixels that are going to be written, is also holding or sort of encapsulating the calls to do that, and we'll see that a little bit later. The next thing that Android uses a lot is a concept called drawable. And a drawable is an abstract class that represents a resource for graphic that can be drawn on the screen and which you can retrieve with APIs, such as getDrawable, or apply another XML resource with attributes. It's just like a generic concept for, we can draw this. And it has a draw method, which is, again, the thing that will actually draw on the canvas the thing that we wanted to draw. And drawables are often used really simply. They can be applied to any view that we know of just by applying a background to that view. We can also set them as a foreground and, again, edit more properties about them. And we're going to talk, again, a little bit about that later by using an ImageView. And there are some classes that Android provides that are extending from the drawable abstract class. I'm not going to name all of them, there's a bunch of them, but some of them that we might see are these that I mentioned here. A BitmapDrawable is a bitmap graphic file, a PNG, a JPEG, or a GIF. And then, again, it overrides the draw method, and on the draw method, it does all the work that it needs in order to show a bitmap. Another bitmap another drawable that you might see around is the StateListDrawable, which is a list of different drawables when we want to say, okay, when a button was focused, use this drawable. When a button was normal, use another drawable. It's like, again, like a state list of different drawables that we might want to play around with and change according to a state of an object, of a view. And another very common drawable is a drawable that represents a shape, a rectangle or an oval. And again, this is represented by an XML that describes that particular drawable, what color it is, other properties that you might want to assign to it. And in the GradientDrawable class, again, the onDraw method is being overridden and with particular instructions to the canvas about how to draw that particular drawable. And I just copy-pasted this example from the source code just to show that it calls canvas with methods like draw a rectangle, again with the information that we need to draw that, to turn that drawable into a bitmap. And the last thing that we can draw on the screen is obviously a view. These are all the views that we know. They also all have a draw method that draws on the canvas. Drawables are sort of a more basic class. They only respond to draw operations, and views can do a lot more. We all know that buttons, images, text views can do a whole lot more. They can respond to user interfaces, events, and they can do a whole lot more of custom operations. So views can contain, obviously, many drawables. And again, if we want to do something special or draw something special on a view, we can always override the onDraw method and override that and draw directly to the canvas. And the canvas is being supplied to views and to drawables from a list of canvases that is basically created by the operating system. So the easiest thing to start off with when we're starting an Android project is to start off with static images. Just add these images to our project and call them from our project, and they'll be displayed in our app. And the way to do that, the way to add static images into our app is by adding them to our resource file folder. And in particular, the drawable folder. And the one thing to notice about this resource folder is that there's another sort of folder that can contain drawables, which is our Bitmap folder. And our Bitmap folder is used for icons for launching our app. And the reason for that is, even though it's identical sort of by structure, and I'll talk about this again a little bit later, you can provide different images for different resolutions. Some operating systems like to display bigger icons for apps. And so that bucket that you bucket your image into might not be used. It might use a higher one, a bigger one. So bottom line is put only your icon launcher into the Bitmap folder and the rest of them into the drawable folder. So I talked a little bit about the fact that different screens have different densities, and as sort of Android developers, we should be prepared for that because we don't want to supply an image that is either too small, because if it's too small, then while scaling up, it will look pixelated, or it's too big, because then we'll just be wasting memory and we'll just be wasting space and storing a really big image, and we don't need it, because the information will not be conceivable to the person who's looking at the app. They wouldn't know the difference. So a best practice in Android is to provide different sizes for the same image to support different resolutions. And so the first step would probably often be get an image from the designer and sort of figure out, hey, what resolution is this? And then scale it up or down, depends again on the size that you want to display it versus the size that you got it from that designer, to different buckets of resolutions. Now, when you provide the same image only with different resolutions to Android operating system, then it will choose the one that matches your resolution, or if that one doesn't exist, say I only provided, I don't know, 2 or 3 out of those, it will just choose the closest approximation that it has to that particular resolution. Now, the way to do it is basically to create different folders in your drawable, in your resource folder to contain all of them. And you can do this manually just by creating them and adding them to your file tree, or there are different plugins that you can use to just feed the image and be like, create different resolutions for this image, I need them. And then in Android Studio will group them all together, but it will sort of mention, give you clues that these are different resolutions, but the same image, the same name, only in different folders. Now, I want to move ahead and talk a little bit about ImageView. ImageView is sort of a more advanced way to display views. You can display them in the foreground, and it's also commonly used to perform operations on an image, such as apply tint and handle image scaling. So I'm going to talk a little bit about the tint and the scale image and the ScaleType. And the tint is just a way to say, color my image in a different color. It's kind of self-explanatory in this case. And ScaleType is a way to say, if my image is a different size than the size that I'm providing for it right now, how do you want it to be displayed cropped, or do you want it to fit? Do you want to squish it, or do you want to stretch it? And this is the best example that I found. This is Amanda Hill's post, and I linked to it here too. And I use it frequently because I don't always remember all the different scale types. And the last thing I want to talk about is dynamic images. So far, all I've talked about are images that I statically added to the app, but often we would want to upload an image from a URL and display a list of images, or display it, again, dynamically based on something that I got from a server. In a very basic level, images are being loaded from a URL as a stream. Then we can create the bitmap out of the stream by using a class called Bitmap Factory that provides this helper method for us that decodes the stream into a bitmap. And then we can take that bitmap and set it to our image view. Now, this code, maybe, I don't know if you've noticed, but already has a bunch of problems. And I want to talk also about what it means to provide a good image experience in an Android app. So the very first thing that maybe you might have seen is that this code was sort of synchronous. And one thing that I would probably want to do just to start off with is load it in the background so it doesn't block my UI, especially if it's more than one image. And again, these are heavy operations that I will need to go over. The other thing that is very important is to handle caching, because if I'm calling the same URL multiple times, there's absolutely no reason why I would keep fetching it and creating new objects for it every time I call it. The other nice thing to do is create a placeholder for my images while they're loading and not sort of surprise the user by suddenly switching into an image. And the last thing that I wanted to talk about is resizing, because again, if we're serving a too small of an image, we will see a blurry image, which the user will not like. But if we're also fetching really big images, then we're holding in memory really big images that will more likely to cause our devices to go out of memory, because these are really big, again, structures that we're holding in the memory, and the difference will not be noticeable to the person who's using the app, so we're just wasting space and causing a bad experience for no reason. So with resizing, we can do two things. One thing that we can do first, and is really sort of easy but requires server-side support, is to ask for an image size that is the closest to the screen that is displaying that image. So if the server will provide us with different resolutions, different images, just ask for the one that is the closest to what we need. And the second one is we can do these resizing operations on the client side, whereas we can do these, we can take a big image from the server side and make it smaller without turning it into a bitmap and then finding out it's too big for the phone and crashing in an out-of-memory exception. So in order to do this, I pasted some code here. As we'll see in a second, it's not really super important that you memorize it, but there are ways to do it. And for example, like what I've shown here is that Bitmap Factory has a way to decode an image without actually opening it up and creating the entire bitmap array, which again could be really big if the image is really big and cause an out-of-memory exception. We can tell it just decode bounds, which means just tell me what size it is before you do anything, before you allocate a bitmap to it and create it. And then from these options, we can get our width and height of the image that we received from the URL. And we can do complicated math calculations to sample it and know which size we actually need, and then tell it to decode it within the size that we want it to be and not in the size that it was delivered in, which will again create a smaller bitmap and save up on memory. Now, if this sounds complicated, it's because it is. And here is when I say all these things that give you a good image experience and seems like would be a big trouble to implement ourselves, are available in the form of imaging libraries. So imaging libraries do all these things that I talked about. They do placeholder, they do caching, they do resizing, they do background loading for us without us having to write all this logic from scratch. Therefore, it's highly recommended to use one. And I mentioned the three sort of leaders in the market, which are Glide, Fresco, and Picasso. And Glide was made by people from Google, but it's not Google official. It supports fetching, decoding, displaying videos, displaying images, displaying animated GIFs. It uses a custom HTTP URL connection, but it also, you can switch that to use Volley or OKHTTP if that's what you're using to fetch your images. And it has a very easy way to configure your cache for individual images. Next very popular library is Picasso. Picasso and Glide are pretty much the same. They have small differences between them. In Picasso, it's easy to crop and resize images. It's easy to handle errors. It handles ImageView recycling and download cancellation in an adapter. So if you scroll really fast up and down on the adapter, on a recycler adapter, for example, it wouldn't continue fetching images that are no longer being displayed because we scrolled really fast. And it supports complex image transformations, such as if you want to do like a rounded image, or if you want to like do rounded corners image with minimal memory use. And the third library that I want to mention is Fresco. Fresco is made by Facebook. And it's the only library that supports progressive JPEG. So if you want to use progressive JPEG, this is pretty much your only option. Progressive JPEG is a way to show images progressively as in low network conditions, which means, say that I have a really big image and it will take a long time to download it and display it on a low network. In progressive JPEG, you can serve lower qualities of the image and sort of replace them gradually with higher and higher qualities of the image until you reach the maximum available image. This obviously also needs to be supported by the server. And on Android 4X and lower, Fresco also puts images in a special region of Android memory. And it also makes sure that images are automatically released from memory when no longer shown on screen. So it listens to onAttach and onDetach. And the one different thing about it is while both Picasso and Glide load your image into an ImageView, Fresco has its own image hierarchy. And instead of using ImageView in your app, you'll need to use something called Drawies. And it also, so you just have to be aware of that it will sort of kidnap your view tree. Now, this sort of syntax is kind of really similar between Picasso and Glide, and a clear example of how this would look like and how this library would do everything for us. It would load something, load a URL from, again, from the web, but into, in the background. I can specify the disk cache strategy if I want to, or use the default one. And sort of a note on that is pay attention a little bit to the caching strategy of the library that you use, because they do have default and they do cache stuff, but you just want to make sure that it caches what you want it to cache. And for example, if you're serving the same image only in different sizes, do you want the same image only in different sizes to be cached differently, or do you want it to be cached as one image and then just be resized and be taken from the cache every time, instead of, again, sort of caching the same image multiple times? You can add a placeholder here, as you can see, and you put it into a regular image view. And yeah, that's it. Thank you.